right, we are going to move on to angles now, guys. And the reason we do sides first is to create an angle, you need sides. To create sides, you don't necessarily need an angle. Although a straight line is considered a straight angle as well. For the most part, as we see it, you do need sides to create angles. So real quickly, an angle is just something that consists of two different rays that have the same initial point. So here we have ray BA, and here we have ray BC. Okay, the sides of the angles are the rays, and the vertex is where those rays meet at their shared initial point. Congruent angles have the same measure, although that can never be assumed. That has to be told to you in some way. And with angles, we either label them ABC or CBA. You always put the vertex in the middle. We can sometimes put a number in the angle and just number it and just measure it, or I'm sorry, just name it like that. We'll talk about that later on. For right now, angles are going to be ABC or CBA. You can name them with just a vertex in some cases. That's a bad habit to get into because a lot of times the vertex of one angle will also be the vertex of another angle, and then you need three letters. So let's be in the habit of ABC or CBA. Protractor postulate is the same as the ruler postulate, except it only applies to angles. When you measure angles, and this is something you should be able to do with a protractor, every angle has one and only one measure between 0 and 180 degrees. So once again, every angle has one and only one measure between 0 and 180 degrees. That's what the protractor postulate is saying. Okay? When you measure angles, please be aware with the protractor, if your line goes to the right, we're using the smaller numbers or the inside numbers. When your line goes to the left down here, we're using the outer numbers. Okay? So line going to the left, outer numbers. Line going to the right, inner numbers. And the other thing you really can do is if you take a look at an angle like this, well, it's going through 60 or 120. This is one time I will let you kind of assume a little bit. In most cases you can't. But if we're actually physically measuring the angle, does this look 60 degrees? Does it look less than 90 or more than 90? If it looked more than 90, we'd probably go with 120. Obviously, it looks less than 90, so we're going with 60 degrees here. Then we move on to our angle addition postulate. Same thing as the segment addition postulate, with the only difference of you're dealing with angles. And essentially what we're saying is two smaller angles, RSP plus PST, these two smaller angles have to add up to make the bigger angle, RST. Okay, so once again, this small angle and this small angle, it doesn't matter what their measures are. We can't assume them. We don't know what they are. But whatever they are, sorry about that, they have to add up to the entire angle. You can't have a piece of the angle equal the entire angle or be more than the entire angle. So RSP can't be bigger than RST. RSP plus PST has to equal the entire angle RST. Okay. And then we have some algebra that we'll go through in class here. We do not set these angles equal to each other. Okay, you're not told that SP is an angled bisector. You can only add them together and set them equal to the whole angle. We have four types of angles: acute, which is less than 90, right, which is equal to 90, obtuse, which is greater than 90 but less than 180, and straight, which is 180 degrees. And adjacent angles are angles that are next to each other. They share a side and a vertex, but no interior points.